Welcome to the next lesson on normal distributions and finding probabilities. Last time, in our last lesson, we learned about empirical rule and how we can use that to find probabilities. For the empirical rule, though, we had to have some pretty strict guidelines. We knew that if a value that we were interested in was not a specific 1, 2, or 3 standard deviations above or below our mean, we didn't have the tools to find that probability. Today we're going to learn how to use a normal table as well as a calculator to help us find those in-between probabilities. To do that, our first step is going to be to draw a picture. We draw a picture describing this. We know it's a normal distribution, so it's going to have this sort of curve. The mean is 23. We always put the mean in the middle. And then 18, that's the value we're interested in. That is below our mean. And we want to find a data value that is below that. So we're going to shade below 18, like I've done here. Now, to help me, I'm going to find the z-score. I find the z-score. I plug in the data value, minus 23 over 4, and use my calculator to simplify, and I get z equals negative 1.25. Which means I can redraw this picture of the standard normal curve once I've transformed my data using a z-score. My mean becomes 0, and I still have that in the middle because the mean always goes in the middle. And then my data value I now know is negative 1.25 z-score. And so I can draw that in. I did my dashed line as my best estimate and then shaded below. So now I can rewrite my problem using some math notation. This says, what is the probability of z being less than negative 1.25? So what's the probability that we have a data value that has a z-score less than negative 1.25? This is really equivalent to what this question is saying. So in order to find that answer, we can use one of two ways. The first way is to use a normal table. And you should have one of these. I gave them out at the beginning of the year. So you can pull that out. Otherwise, there's one in the back of your book. You'll notice we have two data tables, actually. It's one big data table, but we've separated it onto 2 pages for convenience. So one has z-scores. Our first column is z-scores that are negative. One has z-scores that are positive. So for this problem, our z-score is negative 1.25. So I can look on my table and go up to negative 1.2. And then I can go over and I get my 100th place decimal place is above the top. So if I want negative 1.25, I need to go over to my 0.5 column. And I see that my negative 1.2 and my 0.5 column are intersecting at 0.1056. And so that I can say is my answer. So I can take this off. So I say that the probability of having a z-score less than negative 1.25 is 0.1056, or I can convert that decimal into a percent and say that it's 10.6%, just rounding. So that is one way to solve this problem. We also have another method using a graphing calculator. So if we use a graphing calculator, we need to first find a new menu. How we find that menu is we go second, vars, and then we're going to go to number 2. We're not ever really going to use normal PDF in this class. That asks for the probability of having exactly one value. So what's the probability of having exactly negative 1.25 as a z-score? And it turns out when you have a continuous function, like normal distributions are, or a continuous distribution, I should say, that probability is always 0 because there's infinitely many probabilities. And so getting a specific one is so unlikely that we say it's 0. We can actually prove it's 0 using calculus, but I'll save you that. So we're going to use normal CDF. So you'll always go down to number 2. You'll skip number 1. And we're going to try and enter basically what this problem is telling us. And we can do it a couple of ways. If you've already found the z-score, it's pretty easy. Your calculator is going to default to the z-score. And that means that it's going to default to assuming that you have a mean of 0 and a standard deviation of 1. So if I've already found that, I can just plug in my negative 1.25 as my upper bound. You're going to enter your data in your calculator as an upper bound and a lower bound. Lower bound goes first, upper bound goes second. You might be wondering, where did that negative 99 come from? That's not anywhere in our problem. Well, the idea is if we look at our picture, we really want to just shade everything below 18 or everything below negative 1.25. You could say you want to just go forever away, right? Like infinity, all the way, all of those negative numbers forever and ever. Well, our calculator doesn't have an infinity button. And so instead of saying infinity, we just use a really big negative number. When you've converted to z-scores, it turns out negative 99 is big enough. Your answer is not going to change whether you put negative 99, negative 100, negative 512, negative 1,000,012. All of those numbers are big enough to get the same answer. We know that since it's really unlikely, we know that 99.7% of our data is within 3 z-scores. So if we go negative 99 z-scores, that's super unlikely. So I'm going to use negative 99 as my lower bound, kind of instead of like negative infinity. So negative 99, and then I go comma, and I put my upper bound, which is my z-score. That's where I stopped shading. That's the upper bound of my shaded region, negative 1.25. This is why it's really important to draw that picture, because it helps you figure out how to enter your bounds into your calculator. So I plug that in, and if I put the parenthesis right there, that is telling my calculator to assume that the mean is 0 and the standard deviation is 1. So I can do that, and I get 0.1056. I get some more decimal places that my normal table wasn't able to give me. The calculator is able to be a little bit more exact than the normal table, and that's a good reason to use the calculator. But we see that our answer is essentially the same. Now, if we hadn't found our z-score, we could save ourselves some work. We can enter a normal CDF. I just want second vars, normal CDF. And this time I can tell my calculator I still want my lower bound to be essentially negative infinity, only this time I haven't found my z-score, so I want to make that number a little bit bigger just to guarantee that I'm going to get the same answer. So I'm going to put negative 999, comma, 18. That's the data value I'm interested in, and that's what I want to be less than. Now I'm looking at this picture up here. 18, comma, and this time I don't want my calculator to assume that the mean is 0 and the standard deviation is 1. So I'm going to tell it what the mean and standard deviation is. So after I put my lower bound, then my upper bound, then I put my mean, 23. And next I put my standard deviation of 4. And I hit enter. And I get the same answer. The calculator is just doing that z-score calculation for me. You may have noticed that I'm working on a TI-83 calculator. If you have a TI-84, when you hit the normal CDF screen button, you'll get a slightly different screen. It's going to ask you for your lower bound and your upper bound. You'll put the same numbers that we used in the calculator. And then it'll also have your mean and your standard deviation. You'll be able to see that it's presetting your mean to 0 and your standard deviation to 1. And so you can either put the initial values we did, negative 99 and negative 1.25, if you found the the z-score, or you can just enter and change the mean and the standard deviation to 23 and 4, but you should still get the same answer either way. Okay, let's practice some more problems. The next problem says the probability of a data value being above 25. So now we're looking here, and it says we want to find the probability of a data value being above 25. So my mean is still at 23. This time I'm interested in 25, and I want to know the probability of being above 25, so I shade above. I can find my z-score. Now, if you were using your calculator to solve this, you could skip finding the z-score, but I'm going to show you how to use the table again. So I do 25 minus 23 over 4, and I divide 25 minus 23 is 2, divide by 4, and I get 0.5. So if I convert my picture to be in terms of z-scores, 0 is my mean, 0.5 is my upper bound, and I shade above. Now I can describe using my probability notation. So first, I want to find the probability of z being greater than 0.5. That is exactly what we want to find, but we have to be careful for the table, is our table is always giving us the probability of being below a number. You can see that with the shading at the top of the table. So we need to figure out how to find the probability of being above. Well, and how we do that is we figure out that we know that normal curves areas always add up to 1 total. So the area under this curve plus the area, or under 0.5 plus the area above, will always add up to 1. So I can rewrite this problem as being 1, and then I'm going to subtract the area less than 0.5, and that means the answer should be the area above 0.5. So when I do that, I can use my table. I want to find the area below 0.5. So I come here, 0.5, and there's no decimal place after, so my answer is just the 0, 0 column. So 0.0615. So this probability was 0.6915, and I'm still plugging in the 1 that I need to subtract that from. When I do that, I get an answer of 0.385, or rounding that to 30.9%. If we want to use a calculator, we can absolutely do that. Again, we're going to hit second vars, go down to normal CDF, not PDF, and we can plug it in one of two ways. If we plug it in doing 0.5, 99, or 25, the data value we're actually interested in, 9,999. Why am I using the 99 again? Well, last time we used it to represent the lower bound, because our data went on forever below. Now we want the upper bound because our data is going to keep going forever above. So we're switching the 99 to be positive because it's above the mean, and we're going to use it as our upper bound. So I can plug in that way into my calculator. Either way, I'll use the z-score version this time. I'm assuming I've already found the z-score, and I'm plugging that in instead of the original data, and I get the same answer I got on my table. So they'll always be the same. You can just decide what you like better. Okay, now part C asks to find the probability of a data value between 18 and 25. So here we draw our picture, 18 and 25. 23 is the mean, it's in the middle. We're wanting to find the region between them, so we shade between. We already found these z-scores in the previous problems, so now what we need to do is we're actually trying to find the probability that z is between negative 1.25 and 0.5. So it turns out that we're going to find that probability by finding the probability of being less than 25, or the z-score that corresponded to 25 was 0.5, so being less than that. And then we're going to subtract the probability of being less than 18, or its corresponding z-score, negative 1.25. When we do that, we should just end up with that range in the middle. When we used our tables earlier, we already found these values. Z being less than 0.5 was 0.6915 on the table, and Z being less than or equal to, these are both equal to's, but it doesn't matter. Whether you plug in less than or is less than or equal to, your answer will always be the same for a normal table. Z is less than or equal to negative 1.25 was 0.156. And when we subtract, we get 58.59 or 58.6%. We can also use the calculator to do this, and this is probably the easiest one to do on the calculator because you can just plug in your lower bound, which is the z-score corresponding to negative 18, which is negative 1.25, and your upper bound, which corresponds to 25, which was a z-score of 0.5. We want to be between those. So I can plug those in to my calculator, and I just get negative 1.25, comma, 0.5. Again, I'm using z-scores, so it's assuming that my mean and standard deviation is 0, and I hit enter, and I get the same answer I did here. If I didn't want to use the z-scores, if I wanted to save myself that step, I could go second, enter normal CDF, and I would need to enter the original two endpoints. My lower bound was 18, my upper bound was 25, was 25. My mean I need to enter next is 23, and my standard deviation is 4. That goes last. And this time the calculator will do the standard deviations for me, but still give me the same answer. Okay, we're going to stop this video here. We'll continue in another video.